is we have to match the type of antenna which are indicated in list 1 with list 2 we have to indicate. See, the frequency independent antenna is a log periodic antenna. Hence, C is 3. Isotropic antenna is nothing but a point source, which is D is 2. And circularly polarized antenna is a helical antenna, hence B is 1. Aperture antenna is the microstrip antenna, hence option A is 4. So this is the correct combination of matching. A4, B1, C3, D2. Here is on a resistively terminated high frequency lossless transmission line fed by 100 MHz source. The VSWR is found to be 2 and the first voltage minima is measured to be 30 centimeters from the load. And what is the value of normalized load resistance? Here we know that S plus the standing wave ratio, there is a relationship between the VSWR and the reflection coefficient and the normalized load resistance. So if we go through that relationship, we will get normalized load resistance as 2, which is option B is correct. Now the question is, a 6 GHz EM wave propagates in parallel plane waveguide, the separation between the planes being 3 centimeters, its phase and group velocities are respectively. Here, the phase velocity is given by velocity of light under root 1 minus lambda by lambda c whole square, and group velocity is nothing but c by means c under root 1 minus lambda by lambda c whole square. Here lambda c is nothing but 2d for air-filled parallel waveguide. Hence Vp is going to be 5.42 into 10 power 8 meters per second. This is going to be 1.65 into 10 power 8 meters per second. Hence option B is correct. Option is 8 message signals having 2 kHz bandwidth each or time division multiplexed using PCM. The error in sampling amplitude cannot be greater than 1% of the peak amplitude. Determine the minimum transmission bandwidth required if the Rayson cosine pulses with roll-off factor 0.2 are used. The sampling rate must be at least 25% above the Nyquist rate. That is, Fs is 1.25 into 2 FM, whereas FMA is 2 kHz. Hence it is going to be 5 kHz. So there are number of signals are 8. So the amplitude cannot be greater than the 1% of the peak amplitude. The error is going to be delta by 2, that is 2 AM by L. 2L is nothing but 1 by 100 AM. So 1 by L equals to 1 by 100, which gives L is 100, nothing but N equals to 7 bits per sample. See, after getting the number of bits per sample, what we have to do is we have to decide the bandwidth. Bandwidth is nothing but 1 by 2t 1 plus alpha. Here mainly 1 by 2t is nothing but NFS by 2 into N, which is nothing but 7 into 5 into 10 power 3 divided by 2 into 8. Okay, alpha is 0.2. After substituting into the bandwidth equation, we will get as 168 kHz, which is option B is correct. Which of the following is don't care combination and the Boolean expression, which is a simplified version of expression? Here E equals to 0. Okay, A B C D, A B C, D. A B C, D. See here the don't care combinations are this. If we write the expression for these three don't care conditions, this you will get A, B, C. So D is the not only is D is the only option which is not a don't care condition. Hence option D is correct. Question is, an FSK system transmits binary data at a rate of 2.5 into 10 power 6 bits per second. During the course of transmission, wide Gaussian noise of 0 mean and the post-spectral density of 10 power minus 20 watts per hertz is added to the signal. In the absence of noise, the amplitude of the received sinusoidal wave for digit 1 or 0 is a 1 microvolt. Determine the average probability error assuming coherent detection. We know that probability error in case of an FSK using coherent detection is nothing but Q of under root ED by 2 eta. Here A is nothing but 1 microvolt 10 power minus 6, eta is 10 power minus 20 watts per hertz. Here T is nothing but 1 by the bit rate 2.5 into 10 power 6. If we substitute, we will get probability of error is 4.47, which is option B is correct. Next, match the list 1 with the list 2. Here in list 1, the discrete time signal is given, x of n is given. We in list 2 z corresponding z transform is given. So we know that alpha n u of n is nothing but 1 by 1 minus alpha z inverse, whose ROC is mod z greater than mod alpha. Hence A is nothing but a 2. Now comes to B. C minus alpha n u of minus n minus 1 is having the same transform as a alpha n u power n, except that its ROC is less than alpha, which is nothing but B is 3. Now comes to C. Minus n alpha n u power minus n minus 1 is nothing but a differentiation of this one, alpha z inverse 1 minus alpha z inverse mod z less than mod alpha. Hence option C is option 4. Comes to D, remaining option is 1. Hence A, B, C, D 2, 3, 4, 1. So the following relationships holds good. A is the non-minimum phase filter. Here the definition for the non-minimum phase is nothing but, here in non-minimum phase, all the zeros or some of the zeros can be in the right hand side of the S-plane, but all the poles must be towards the left half of the S-plane. Whereas in minimum phase filter, all the poles as well as all the zeros must be in the left half of the S-plane. Comes to all pass filter. In case of all pass filter, poles and zeros are exactly a mirror replication. Means for a stable system, the poles must be in the left half of the S-plane. Means the zeros must be in the right half of the S-plane for all pass filter. So that we can arrange like this. After knowing to the definition of the A, B, C, we came to know that option A is the correct answer.